Last time I was here, I was having a few chats with people, and it's clear that although everyone knows about a lot of the individual practices that we do for the DevOps discipline, not everyone has heard of everything. And you hear about something from another person, you think about it a different way, and perhaps you think, how can I use it? So we all want to get into this DevOps, even if you're not in some kind of startup. If you're in a big company with lots of legacy stuff, then you want to get the good effects of it. You want the quicker time to market and development cycles. You want better resilience for your operational network, and you want to use agile techniques for your development. And DevOps fits in with that. But if you've got legacy systems, then it's difficult to change them because they're more complicated than something that's been built from the ground up. Often the resilience is poor because it's an old system and there'll be single points of failure all over the place. And quite often there'll be resistance to using Agile effectively. There'll be things like people saying, "Oh, I'm going on a training course on Prince 2 and Agile." And you're thinking, well, no, I don't think you are. And so there's that kind of thing. So what can you do to move where you are at the moment in the legacy environment to some better place where you're a bit nearer this kind of idea of rapid deployment and resilient systems? So that's what I'm interested in talking about today. So the best way to improve on stuff is with little incremental increases. If you're within an organisation that isn't fully sold on the idea of on the DevOps ideas of rapid deployment and using agile techniques and things like that, if you can improve one little thing, then you can go in the right direction, then you've improved. And if you can keep doing that, then quite quickly actually you'll find that there is some kind of improvement in where you are. You'll find that when you come to, if you manage to implement tests, for instance, when you come to, in a sort of global way, when you come to refactor something in an emergency, you think, oh well, I can just fix that. The test will show that it basically works, and we can push it further down the line than we would be able to before, because we can be sure that it's not going to break everything. So things like that, you can put those in, and it will help you along the way. And this is a sort of well-known thing in bigger companies. They always have interest in this kind of idea where you have a cycle of continuous improvement. Everyone is into this nowadays, and if you can somehow plug your little improvements into that process, then you're more likely to get some kind of buy-in. So I've got 10 specific little tips. So this is my first one. So, like I say, when I talk to people here, a lot of you are already doing this stuff. So feel free to zone out if you want. But so automated tests on commit. So if you've got code and you go from it being written to it being in your stuff that's ready, then at that point you want to do a sort of some testing there, and you can do that automatically because there's a particular step you get to in your process. So any sort of testing at that point is, however basic, is good. And an example of this is static checking. So if you're not familiar with static checking, because I'm just saying, this is the basic stuff, and there's a lot of people that haven't heard of this because they've come from a slightly different angle. If you haven't heard this static checking, it's checking that's on a program that isn't running. So it'll be just looking at the structure of the program. There's many different types of stuff. If you want to look up a particular system that you're using, you just Google for things, lint your program, whatever it is you're using, it'll come up with something. Lint is an old program that used to be run on C systems, and it's often used as a thing that goes with, so it'd be lint puppet or lint whatever. So that's one thing you can do. Another sort of basic test you can do is, does it compile? So if you use the built-in, the blast from the past, if you use the built-in Perl thing for making packages, it comes up with a stub test. And what that does is it loads the module, and it, like a use or an import or an include, it loads up the module and just say, will it load up as the library thing that I've written? And that is the test. And you can do that in, this is it in RSpec Puppet, it's that kind of thing. So it just says, I've written a class called IOPP Tomcat, and will it compile with all dependencies? And that will just load that up. So I've got that as a boilerplate item for all the classes that we've got, and it runs them every time we do a commit, just to check that nothing's really basically broken. When I first looked at the Puppet stuff we had, a contractor had done it for us, and there were like lots of classes. I think I've reduced it now to about 30. None of them had any tests. So I added this to all the modules, and then when I change things now, I'll add more bits to these basic tests. I'll say it should do something else down at the bottom there, and then that makes it gets you somewhere with your testing, and then you can expand it as you go along. So the next really basic thing is Git. So if you're not using Git and you are trying to write software and manage it, then you should be, because it's got all kinds of advantages if you're trying to do this kind of work. That sort of weird looking racetrack diagram is showing a Git branching model. So you probably make out it's you have kind of a master track with tags on it, and then you've got development track, and then you've got feature branches off that, and they all go off, and then you can split off the work you're doing for a particular feature, check it works, and then merge it into the development, and you do more testing on the development thing, and eventually it goes back to the master, and it supports your workflow. And Git is far better at that branching and merging than many other tools. There's a great YouTube thing with Linus Torvalds talking about how Git is better than everything else. And if you want more inside track on that sort of thing, his talk is far better than I could put it. But yeah, so next thing, making packages. So where I am at the moment, we are using Puppet for a lot of the configuration stuff. Where I was before, we didn't have Puppet, but we had facilities for making Debian packages. And they have you can put little scripts in them. They configure your machine. You can do repeatable deploys. You can do all the kinds of things that you need to do to support rapid deployment, like building test environments easily. It's kind of a basic thing that will move you down the road. There's a tool you can get called FPN, which makes it really easy to build packages. You just have a directory with all the stuff in it, and you do FPN, make me a package, and then it just makes it. There's no messing about. With Debian, the learning curve on trying to get a package to actually build properly, once you get past the hello world kind of stage, is a bit interesting. They've got lots of little programs called DH underscore something or other, and but it works great. But FPM is much, much easier for just getting there in the first place. Just talked about that. That's the things like the Debian stuff. And then you might also want to have your own package repository. So with the Red Hat world, they've got things where you can add groups of RPMs that are held in servers out there. I forget what the system is called for adding a set of RPMs, but that's sort of well understood. But if you want your own RPM repository, that's quite easy to do as well. You just basically need something a bit like a web server, and then you tell it where it is in the configuration on the machine, and then it will load up packages that you've put on there. So you can make your own version of Tomcat with a lot of the configuration you're going to use, and install it straight on your server from RPM install, or your own version of Apache or Nginx, or any of these tools that you want to start off with a package. But you think, oh well, I always want it to have loads of sockets or something. You can just reconfigure it, make a package, put it in your own repository, and then you're away. We've also used it with it probably breaks some kind of license or something. We used it with Oracle XE, using that on something or other. And rather than getting this huge file from out on the net somewhere, it's on our in our package repository, and we just pull it out of there so we know which version we're getting, and it can be quicker as well. So that's quite fun. The other thing with making your own packages is it's not just a bundle of files. You can have little scripts that it runs before it installs and after it installs, and that can help you set things up if you don't want to use Chef or Puppet or something like that. Right, the next one is a bit more, it's not so much a tool, it's more a sort of point of view. So I've seen lots of times when I've had programs that have been tested, they're supposed to be ready, they're supposed to be feature complete, they're supposed to be really great, and we've got someone to develop it, or we've developed it or whatever, and you think, oh, it runs on the development machine, let's set a date, put it on the live, and it just doesn't work, it's appalling. And you go through the logs and you discover that something can't write somewhere, or something can't read somewhere. And then you find out that when the people developing it, everything was set to, everything is allowed to read and write everywhere on the development server. And that's not the way you want to do it in live. You always have a system of minimum privileges and least privilege on live servers, so you can't have one process going berserk and deleting everything off the server, things like that. You don't have programs that run as the super user root admin, because for the same reason. But in development, that seems to be allowable. But what I'm saying is, don't do that in development. One easy thing you can do to make it quicker to get your software from development into live is to start using the security policies or similar kind of policy in development as you do in live. So on some of our servers, we've got the in live it runs as services, and in the test machine it runs as services_dev. So they're not running, the thing's not running as root or some kind of privileged user, it's running as a specific user that's attached to the application. And you want to apply the same thing to firewalling and port filtering if you can as well. Again, in pre-production, you might be allowed to just go out on the net and download things and whatever you like, but you wouldn't necessarily want to do that in production. So there may be a rule in production that says, oh, we're not going to allow that. The machine, you install the software and it breaks it. So you can avoid that by applying the same kind of policies in pre-production as you are in production. Right, the next one is, these are supposed to be easy wins, but the question I'm asking is this an easy win? So quite often there are applications where it's been developed, and the worst case that I've seen is we had a mule application that was written by offshore contractors, and it produces several gigabytes of logs every day, because everything, it does a thing called fingerprinting, where with the publishing data that we put out, it looks at articles and it finds the fingerprint for that article, and then it can find ones that are like that. And there's a service for doing this, and every time it tries to do that, with all the thousands and thousands of hits we get all the time, every minute, it's logging everyone individually. So these logs are just massive and unreadable and useless for anything. So you want to eliminate anything like that. Normal activity shouldn't be logged, exceptions should be logged, and things that are unusual. It's easier for you to just look at a log and say, oh yes, that's what's happening, and it's easier for you to set up tools so that they can monitor the log and say, oh look, there's an exception here. If you're trying to filter through lots and lots of stuff, there's a chance you'll get a false positive from just normal activity. Whereas if it runs completely clean, then you know that almost everything that goes in the log is going to be an exceptional message. So it's easier, that's what you want to monitor, so you're already halfway there. Right, now, I think we all know this bloke, or is it you perhaps? I'm looking at you, Andy, here. So this man is making wine, and the way he's making it is he's got a load of old bottles and cling film, and I'd imagine he's got yeast, and he's probably taking his socks off, and I'm sure the result would be interesting, but it's all a bit kind of manual, and you really wouldn't want to turn up and say to you, this is going to be how we work. So if you want to just churn out the stuff, you want a big machine that's going to do it all for you. So when it comes to software, you don't want to be the guy with his bottles and cling film and siphons. You want to have a big factory that will have machines in it, and they will do the stuff that you want to do. So as far as software production is concerned, you need to automate absolutely everything. If you don't, then there's always a chance that just in normal operation, just doing ordinary everyday repeated things, you're going to make mistakes, you're going to waste time. If you do it automatically, it will just happen, and you remove the human error from the process, hopefully. So my next one is putting operational requirements into your planning. So quite often people will think, oh yeah, we can back this up as we're running, but they've not thought the system has got to be stopped to get us a consistent copy of what it is we're doing. Or they've thought, oh, we don't want to make it so it live mirrors everything because that'd be too much space or something like that. You have to think of how would I cope with the different situations that I need backups while you're actually trying to set the system up. And the same with updates. This is particularly important for if you want to do continuous development, So if you want to be updating all the time, you don't want to have to stop your live system every time you do an update. So we've got a system which has got Tomcat, and it's got 5 services running off it, separate Java kind of programs hanging off this Tomcat thing. If you want to replace one of them, you have to stop all 4, and then you have to wait for about a minute while everything loads up and comes up again. And if that was the only node we had, then everything would be sort of on diminished power and paused and not working for about a minute, and that just wouldn't be acceptable. So I mean, with that system we've got it clustered so that the other node will take up the slack. But you've got to think of how will I do updates so there's not going to be any downtime. If you can do that, that makes it much less painful to do continuous integration. And the other thing that you should try and weave into your planning is getting rid of old legacy systems. So, for instance, with our systems, we've got 1, 2, 3, 4. We've got Oracle, Postgres, MarkLogic, and file system, all storing similar kinds of data because they're all from different legacy generations of different software, and we've got it all running all at the same time. So there's a program that someone wrote called Uploaderator Synchronizer, which is supposed to merge the different databases together as new data is added. And it was only, as far as I understand, it was only supposed to be there for a little while before they got rid of one of the things, one of the Postgres, I think it is, but because they never did. So they've got this thing running, and it goes wrong now and then, and it's a bit of a nuisance. So that's trying to think, how can I simplify the system is another thing. Well, if you've got a legacy system, if you can simplify it, then you're moving nearer to being able to do continuous development and rapidly changing things because you've got less estate to consider. My 8th one is configuration problems. So when you add a new feature to your system, quite often the new feature will come with extra configuration. So say you want to send out email, you weren't doing that before, you want to add a mail server, you add it to configuration, put it on the server, you bring it up, you have a go with it, and perhaps because of the security policy or something like that, it doesn't work. So you roll it back, and then lo and behold, it isn't working again. You think, oh no, I've rolled it back and it's not working. And it's not working because you've changed the configuration and it won't load because of the old configuration. So you have to try and test your configuration changes as well as the software changes. So devise some way of testing that. So when I've done this in the past, I've just brought up a VM, put a load of configuration stuff on it, and then see if it starts up, and then rolled it back and see if it starts up, and seeing exactly what it is I have to do to make it work consistently. There's this system that Andy's keen on called Test Kitchen, which will do all that stuff auto-magically, and he can tell you how to do that if you really want to. If you put some kind of version control, obviously if you're using something like Git, you have it version control all the files and everything. But if you have a version inside the configuration file, so saying this configuration file is version 1, version 2, whatever, then you can check that in your application program, and then it will be less confused about what it is seeing, and that may help you to be less confused. Number 9, with a picture of squirrels. So in our business, we've got a kind of operations department who deal with everyday running, and we've got a development team who deal with new developments. And so DevOps is a kind of combination of the two. So if you've not reached that stage where they are like fully merged and combined and working together, then if you want to try and get to that point. So one way of doing this is by getting them to cross-train each other. So from operations into the dev team, knowing how to make these RPM things, how to use tools like TCP dump, how to use things like copying files with tar. Devs don't seem to know that sort of stuff, but you can say to them, this is how you do it. Oh, they're really pleased about that. And then the other way round, devs know about how to use Eclipse and how to use Crucible and what Pepe is, and operations don't, and maybe they should, because they are really useful tools. If you're going to start using Puppet and software infrastructure control, you need to know about software tools. Devs know about software tools. They can tell you about it. And then my final one is, you've probably heard the DevOps people saying, "Oh, you shouldn't have servers that are like pets. They shouldn't be individually tailored and made to go with lots of work. They should be like cattle, where we just breed them up, fatten them up, and then once we're finished with them, we shoot them. We don't worry too much about it." So what I'm saying is that you should apply the same thing to other features in your development cycle. So don't get attached to something just because it's a cool kind of DevOps thing. Like for instance, we were going to do a new project, and someone on the dev team started doing the project without any input from us, and they said, "Oh, you're going to use Docker." We did discuss it, and we used to use it. So I said, "Well, hang on a minute, there's lots of things that in operations we just can't do at the moment with Docker. We'd love to use it because it looks like it could be really useful down the road, but there's a really tight deadline on this project and it's just not going to happen." So we had to shoot that idea, and the crazy ideas are good, but making small changes is better because it gives you more predictable come out.